Right, to help us out, I've drawn the formula of the area of a sector up next. We're going to be using that shortly. So this is a cross-section of a park bench, which I'm honest, I reckon if you sat on that, you'd probably slip off. There doesn't seem to be enough room for a full bum, but hey, we're not here to question the questions, we're here to answer them. So we need to find the area of the shaded bit, basically, of this 2D shape. It's tried to make it more complicated, but it's not. So there's two parts that's made up of. One is a rectangle, which hopefully is easy to work out for you. That's just going to be 8 times 32. So I might try and do the whole thing in one go here. Let's see, 8 times 32. But then we're going to have to add on this next bit. Now, this next bit's a bit of a pain in the neck. I'm going to use brackets for it, even though I don't need it, just because it helps keep things clear. This curved bit. Now, we can find the area of whole sectors easily. Finding the area of that, though, we just need to find the area of, like, that whole bit. Let's just say it went all the way up to the outside and down. And then take away the area of the white sector there. And all we need to do for those two things is know the two radii, which we do, 48 and 40, and then plug them into this formula. So either you just need to remember this or just think about it. It's basic. It's just a fraction of the area of a circle. So how much of the whole circle is this? Well, it's 125 3/60ths, because degrees are just a fraction of a circle, a fraction turn in the end anyway. So 125 3/60ths. So I want to do this big one first. 125 3/60ths multiplied by pi r squared. Then not r squared. The radius of the larger section is 48, so going to be big. Excuse me. Then we need to take away the smaller one, which is still the same fraction. The circle still uses the same pi. However, the radius is a little bit smaller. It's going to be 40 squared. So this section here gives me the area of the curved bit of the bench, and this bit here doesn't. So I'm just going to write that a bit more for you in terms of pi. So this here is 256. When you simplify this one out, this larger one out, I believe it gets you 800 pi. Satisfyingly round number, considering it's got 125s, 360s, and 48 squared, things like that. Lovely. And then subtract a not so nice number, 5,000 over 9 pi. Anyway, when you do all that, you get 1,024. Now, it is important that I have, for once, gone to more than 3 significant figures, because the question says calculate the area of the cross-section correct to the nearest square centimetre. So, 124 centimetres squared.